Hello and welcome back. Now that we have learned about the construction grids, we would use the same to create our goalpost frame model. Now we have already created this goalpost frame model in two ways. Once using the text editor, and on the other occasion we used the node coordinates table and the member incidences table in the graphical user interface. But before we go ahead and do that, please take a moment to hit the subscribe button and join us in this wonderful journey of learning structural analysis with STAAD.Pro.
So just as a reminder, this is the STAAD model of the goalpost frame that we had created last time using the graphical user interface. Now the view of this frame is isometric, which is by default. Now in order to view this frame from the front, we go to the view option and select the front view option. Now today I will show you a very special tool that can be used to measure the distance of a node from another node. This can be utilized to measure the dimension of the structure. So for this, you need to go to the utilities option and select the node tools and click the node to node distance option. You'd see that the mouse has changed. The mouse cursor has changed from what it was by default. Now if we click on node 1 and then click on node 4, we can see that the distance between node 1 and node 4 is being displayed, which is 5 meters, which is also the width of our frame. So thus we can utilize this tool to display the dimensions of the frame. In order to measure the height of this frame, whether we have modeled it correctly or not, we can measure the distance between node 3 and node 4, or we can measure the distance between node 1 and node 2. So let us try and measure the distance between node 1 and node 2, and we see that the height displayed is 3 meters. Now if we recall the dimensions of the frame that we had tried to model, the width of the frame was indeed 5 meters and the height was indeed 3 meters. So this is a proof that the dimensioning or the measurement that we have modeled is accurate and correct. There is another tool that I wanted to show you. If you go back to the node tools, you would see that there is another tool called remove node to node distance. Now this remove node to node distance would become active only if there is at least one dimension on the screen that is active. So if you haven't activated the dimensions, any dimensions in the model, this remove node to node distance would be inactive. Now as we have seen that we have actually displayed the dimensions of this structure on the screen, remove node to node distance option has become active. Now what would happen if we click on this option? If we click on this option, the dimensions would disappear like this. Okay, so this is something that I wanted to show you because this is an extremely useful tool to measure the various distances in your model, which can help you verify whether your modeling is correct or not. Now let us recreate the same model that you see on the screen using the construction grids. In order to model a new STAAD file using the construction grids, let us create a new STAAD file and let us name the file as modeling the goalpost frame underscore using construction grids. We select the model as analytical and we select the units as metric and we click the create option to get into the modeling area. Now let us create the construction grids in order to create the goalpost frame model. So let us go into the grids option as we had done like last time and click on the beam grid option. Now let us create a new grid by clicking on the create option. Let the grid be linear, and we can just name this linear grid as goalpost grid. And the plane, now since it's a plane structure that we would be trying to model, we would select the plane as xy. Angle of plane would be 0. The grid origin would be the origin of the global axis system, which is 0, 0, 0. And let us create, remember that our goalpost frame had a width of 5 meters. So let us create one construction line to the right at a spacing of 5 meters. And if we remember, the height of our frame was 3 meters. So let us create one construction line at a height of 3 meters, and we click on OK. Now let us try to understand the grid that would be created due to this specification.
Now, the grid that we would have created would look like this actually. Let this be the grid origin, right? Remember that our grid origin again, so this was the grid origin, and our grid origin again was at a global coordinates of 0, 0, 0. And remember that we had only one division on the right of the grid origin at 5 meter spacing. So this is just a one division. So the distance between these two vertical lines is 5 meters, right? It is 5 meters. And then we had one division above the grid origin. So this distance between these two horizontal lines is 3 meters because we specified the spacing as 3 meters. So now you can definitely see that the point, the grid origin is where the coordinates are 0, 0, 0. So the coordinate of this particular point would be 5, 0, 0, right? Because the spacing was 5 meters along the x-axis. The rest of the things didn't change. In this case, the coordinates of this particular intersection point would be 0, 3, 0 because it's changing along the y-axis. So remember, right? This is the y-axis and this is the x-axis. So, and this is the grid. Okay, this is nothing but the grid lines, the imaginary lines. Okay, this is not the actual members that we have modeled. We have only modeled the imaginary construction grid lines that would help us in creating our models. We'll see that how, but that's for a later discussion. But now, the coordinate of this particular point, this particular intersection point would be 0, 3, 0. Similarly, what would be the coordinates of this particular point? It is 5, 3, 0. 5 and 3, so it would be 5, 3 and 0. Now you can see that all the corners of the construction grid have the coordinates of the nodes of that goalpost frame. So all that we need to define is to take our mouse cursor there and define the nodes at the intersection points, and we would be done with our goalpost frame modeling. Now we'll see that how.
So let us view the construction grid that we have just created. So let us click on the goalpost grid that we had created, and we can see that the grid is exactly what we have explained on the board. Let us view this construction grid from the front. Now we could see that the snap option is being turned on. So all that we need to do is to start by clicking on this point. So as soon as we click on this particular point, node 1 is created. Now we take our mouse and we would click on the position of node number 2, which was, if you remember, at coordinates of 030. So if we click on this, node 2 would be created, and along with it we will see that member number 1 has also been created. Now if we take our mouse and click on node number 3, or this point that would represent node number 3, which is located at a coordinates of 530, 5 for the x coordinate, 3 for the y coordinate, and 0 for the z coordinate. If we click on this, node 3 would be created, and along with it the beam number 2 or the member number 2 would also create it. In the same fashion, we go on and click on this final point to create the node number 4, and along with it beam number 3 would also be created. Okay, so our construction grid is now complete, and we can turn off the snap node beam option to turn off the snapping, and we can close this box to remove the construction grid from view, and we would see that all the coordinates of the nodes, all the nodes with all its coordinates has been represented in the node table, and all the member incidences of all the members created has been represented in the member incidences table. Now, in order to see whether we have registered this information in the text editor, we go to utilities and we go to command file, click on save, and we'd see that all that we had defined on using the construction grid has indeed been registered in the text editor. All that we need to do is to go in here and change the space to STAAD space to STAAD plain, and we can come out of the editor now.
So I think you could appreciate how quickly we could create the goalpost frame model using the construction grid. This construction grids comes to be extremely handy when the structural modeling gets complex. Now we have covered all the aspects that we wanted to consider for the modeling of structural geometry. However, there is one final aspect that we would discuss in our next session that would relate to the modeling of geometry. And after that, we would go on for modeling the properties and material specification. If you have liked this video, please hit the like button and please press the bell icon for more notifications from the Structural Insider channel. See you in the next one. Till then,